Hi everyone, meteorologist Gary Woodall here, and welcome to this episode of the Mid-South Weather Musings. In this episode of the Musings, we're going to look at May 11th and a couple of the historic tornadoes which occurred on this day, talk about some of the devastation that those tornadoes brought, but also some of the important findings and information and outgrowth that came from those tornadoes. Stay tuned, episode's coming right up. So when we throw out the date May 11th, the fact that tornadoes occur on this day probably is not a real big surprise to you. May is near the historical peak of our spring severe weather and tornado season, so tornadoes occurring on May 11th probably not that big of a deal. But there have been a number of significant, destructive, historic tornadoes which have occurred on May 11th, and we're going to focus on two of them in this episode, 1953 and the May 11th, 1970 tornadoes. The May 11th, 1953 event struck Waco and San Angelo, Texas. Two different storms, two different tornadoes, about 150 miles apart. These were deadly events, 114 deaths in Waco, tying it as the deadliest tornado in Texas's history. An additional 13 tornadoes in San Angelo. Now, this was well before the Fujita scale for rating tornadoes had even been considered, but had the scale been around, these both probably would have been rated at least EF4. In fact, the Waco tornado probably would have been an EF5 or an F5. Now, since this was in 1953, a lot of the infrastructure that we think about with severe weather really was just being developed. CELS, which later became the Storm Prediction Center, weather radar, severe weather warning systems, really all in their infancy back in 1953. So we're going to look now at a series of weather maps and how the weather situation evolved on May 11th, 1953. On the maps, you'll notice the purple dot here, that is Waco, and then the purple dot to the west, right here, that is San Angelo. So at 9:30 in the morning, we had a dry line over West Texas. This dry line separates dry air to the west from warm and moist air to the east. And there was strong southeasterly winds that were bringing this warm, moist air up into the area, including the San Angelo and Waco areas. There was an early morning cluster of thunderstorms which formed over what's called the Big Country area up here near Abilene, and those early morning storms actually pushed an outflow boundary down into central Texas. By 12:30, the outflow boundary was draped still across central Texas. Some new thunderstorms formed along the outflow boundary here to the west of Waco. Other scattered thunderstorms had formed along and ahead of the dry line and were moving northeast towards San Angelo. The San Angelo tornado struck at about 2:30 in the afternoon, and it looks like this outflow boundary may have been draped right across the city at about the time that storm came across. Outflow boundaries are notorious for helping strengthen and enhance the low-level rotation in thunderstorms, and this outflow boundary may have played a role in strengthening and intensifying that tornado as the storm crossed the boundary and moved through San Angelo. By 4:30 in the afternoon, the outflow boundary still lingering over central Texas. The San Angelo thunderstorm that produced the San Angelo tornado had dissipated by this time, but a new storm had formed to the south-southwest of Waco, started moving to the north-northeast. It may have ridden right along this boundary, this outflow boundary, into and through the city. So again, this outflow boundary could have played a role in strengthening the low-level rotation and enhancing the intensity of the tornado that formed and moved across Waco. The Waco tornado itself developed at about 4:10 in the afternoon southwest of the Waco metro area. It was on the ground for 23 miles, although the beginnings of this path, it was just intermittently on the ground. It was 600 yards wide and dissipated at about 4:55 in the afternoon up here northeast of Belmead, northeast of the Waco metro area. There was damage that would have been classified as F5 on the Fujita scale. And this tornado gathered national media coverage, national radio network coverage. Newsreels were produced showing and describing the destruction that the tornado brought. Now, tornado forecasting was very much in its infancy in the Weather Bureau in 1953. At this time, the U.S. Weather Bureau, our main national office, issued daily severe weather discussions. They actually started these in January, so it had only been doing these for a few months, and these were sort of equivalent to the severe thunderstorm outlooks that the SPC produces today. The district offices, the local Weather Bureau offices, then issued what were called severe weather bulletins. These were somewhere in between a watch and a warning using our today's terminology. These were issued via teletype, not the fastest communication system, but it was the best they had at the time. And the Severe Weather Bulletin for May 11th of 1953 was focused on the red highlighted area here. That was the area of concern. And interestingly, San Angelo and Waco were two of the corner points of this bulletin area. So San Angelo and Waco figured prominently in that forecast in 1953. Now, following the tornado and the weeks and months that followed, a lot of meetings, a lot of collaboration took place. Texas A&M College at the time, now Texas A&M University, had an early model weather radar on campus there in College Station. And they observed a peculiar sort of a comma or kidney bean shape to the storm that moved across Waco. So again, some of the early value that weather radar might be able to provide. There were a lot of other meetings and conferences on improving and enhancing the severe weather warning system as well. Moving ahead 17 years to 1970 and the Lubbock tornadoes, two tornadoes which struck the city on the evening of May 11th, 1970. 26 deaths resulted, somewhere around 500 injuries. Over 8,000 homes damaged or destroyed by the tornadoes, most of that caused by the second of the two tornadoes which occurred. This was really a defining moment for the city, really changed the course of history for the city of Lubbock. There were some significant meteorological findings that came from the studies of this tornado and the damage that the tornado caused. You can see some of the just almost complete destruction in the pictures here, severe damage in the bottom picture down here. The picture here in the upper right shows what at the time was called the Great Plains Life Building, and it suffered a direct hit by the tornado. You can see all the windows that were blown out. This building is about 270 feet tall, and it was actually torqued about 3 feet by the tornado's winds. You can even today go to the southwest corner of the building, look up, and see a bend in the building just about halfway up. Since this was 1970, we were still doing manual weather observations at the time. People that were manually recording the cloud cover and the temperature and the dew point and the winds. And this is the page of their manually taken weather observations on May 11th, 1970. You can see not a lot of extra writing here in the first about 3/4 of the day. A lot of extra writing down here in the last quarter or so of the day. And looking at some of the remarks that were written out by the Surface Weather Observer, a funnel cloud reported by the public, 0110, that would be about 8:10 in the evening, Central Daylight Time. Funnel cloud probably associated with the first tornado off to the southeast of the weather observing site, which was out at the airport on the north side of town. A little bit later, 2-inch diameter hail fell at the office. They actually had 2-inch diameter hail twice that fell at the office that evening. Also, report of the tornado on the ground 4 miles south of the airport. Observation 10 minutes later, tornado on the ground 1 mile south of the airport. Observation 3 minutes after that, tornado in the vicinity of the station moving to the northeast. And then 10 minutes after that, tornado moved over station abandoned at what would have been 10 p.m. In the evening, and they returned at 10:08. So the weather office, the Weather Bureau office in Lubbock was hit by the tornado. You'll see that here in just a minute. So here we see the tracks of the two tornadoes. Again, the first tornado over East Lubbock about 8:30 in the evening. The airport and the Weather Bureau office up here at the top center of the picture. So again, the funnel cloud reports were down here 7-8 miles to the south and southeast. And this storm, we mentioned the 2-inch diameter hail that fell at the Weather Bureau office. This storm actually produced grapefruit-sized hail in eastern portions of Lubbock as well. The second tornado developed around 9:35 or so, right in central Lubbock, moved up just past Texas Technological College, now Texas Tech University, through the downtown area, north central Lubbock, into some of the residential areas on the far north side of town, and to get eventually out to the airport and the Weather Bureau office. And this tornado, the second tornado, did produce what was documented as F5 damage. So some of the meteorological findings from the Lubbock tornado. Dr. Tetsuya Ted Fujita, who prepared that tornado track map on the last slide, by the way, also did a detailed study and analysis of the damage patterns caused by the tornado. And he observed swaths of strong damage in the overall damage swath of the tornado. And this sort of strengthened and refined Dr. Fujita's theory of multiple vortex tornadoes. And of course, we know today that a number of the significant tornadoes that we see are multiple vortex. They have this multiple vortex structure, several smaller circulations rotating within the larger tornado circulation. Dr. Fujita also used the damage from the Lubbock tornado to tweak and refine the Fujita scale that he developed. And that's, of course, the familiar F scale that we used for many, many years to rate tornadoes based on the damage that they cause. Of course, in the early 2000s, the tornado scale, the F scale, was revised and expanded into the enhanced Fujita, or the EF scale, which we still use today. But again, a lot of the refinements to the original F scale came from studying the damage in the Lubbock tornado. So that's going to wrap it up for this episode of the Mid-South Weather Musings. If you like this type information, if you like learning about weather history and severe weather history in particular, if you like the updates that we provide, then let us know. If you're watching on YouTube, subscribe to our channel. If you're watching on Facebook, like and follow our page. That way you'll be notified of future episodes when they hit the press. If there are any topics that you'd like us to cover, mention those in the comments section as well. We'll try to work them into a future episode of the Musings. But thank you all again so much for watching this evening. Hope you found this informational. Again, some of the background, the roots to some of the severe weather infrastructure and terminology that is still in use today. So thank you all again so much. Everybody keep safe.